How are you, sir?
I didn't see you around, so I know that you are chair here, so...
How much do I owe you? Here. Thank you. See you, thank you.
Next time...
Hello, everyone. So we're going to get started pretty soon. You want to take a seat or your conversations elsewhere? Hello, everyone. So welcome to the INTAREA session. Great. Thanks, Carlos. That's going to help. So welcome to Montreal. Bonjour tout le monde. Word of advice, say bonjour, and then you can start in English. That will get you through in Montreal. That's the local policy. So Juan Carlos Zúñiga, Wasim Erickson, and this is another well. I guess most of you know it, but still a reminder to you that you participate and you agree to follow the IETF processes and policies. That all that we are saying is being recorded, and if you have any questions or want more details, please check the details. So the minutes are taken, the meeting is recorded, the presence is logged, so blue sheets are going around. Please write your name. Can we have someone helping us with the Etherpad? Ian is not in the room right now, so he's usually very kind and very good at notes, but can we have help from someone else on taking notes? It's an easy meeting. We don't expect much debate, so just copy-paste the agenda, put some notes. Yeah? Anyone? Scribe for the Etherpad, please. We do need some scribe to hold the meeting, so. Anyone wants to be volunteered to take notes?
As soon as Suresh is here, I can do it. Suresh is not here.
It's true. Or can someone start?
Well, I will take notes for the parts that's not my presentation.
Okay, fair enough.
You're okay, notes.
Thank you. Thank you very much, Tommy.
Thank you, guys.
Excellent. So we have Tommy with backup. Great. So Jabber, do we have someone for Jabber? Someone that can relay the questions from Jabber? Please. Thanks. Thanks, Eric. Great. So the agenda, this time it's actually a light one. We'll give you the usual update. Then we have Tommy presenting, so we'll meet back up on the notes there. Then we have Ron, that is going to talk about the IP protocol segment routing, Vladimir on SOC protocol, and then Dave on guidelines and registration procedures for interfaces, types, and tunnel. Right. Any bashing or any comments to the agenda? Okay, hearing none. we move on to the shares update. So we have two drafts now on ISG evaluation. The IP fragmentation considered fragile. So it's right now the very last steps in ISG evaluation, and also the GUI. We have it there. There's some revisions needed, but no more major things. So no publications, but at least these two drafts have advanced pretty well. Cool. So without further ado, maybe we can move to Tom.
TD Tracker seems really slow right now. Is it? Yeah, I wasn't actually able to get on Data Tracker. Oh, there's. Okay.
Yeah, it is slow.
It's very slow. Oh, thank you. All right, hello everyone. So I'll be sharing our updates on the provisioning domains draft that we have here in INTAREA. It is actually in working group last call. We didn't get a ton of feedback, but we did get some very good input from Ted Levin. So I want to cover what were some of the updates we have in version 05, which is the most recent published version. And a lot of these were in response to the sector review that we got. And then I also want to cover some of the points that were brought up in the most recent review during the last call from Ted. We are currently in progress on building a 06 version. And what I want to do here today is get feedback from the group on some of the changes and decisions that we're making based on this feedback, validate that it's what we want, and if we are happy with it, we will push a new update very shortly, hopefully this week. All right, so to start out with the updates in version 05. So I think some of the overall feedback that we got from the sector review was just kind of needing more clarity at the beginning through the intro of the use cases, how provisioning domains and discovery of multiple provisioning domains is really enabling a user who's on a network connected to one Wi-Fi router to be able to discover multiple uplinks and what is the actual user scenario driving this, and what are the security guarantees or lack thereof. So we added a bunch of text for more user examples here. Additionally, we had some modifications to how we are doing the PVD additional information. And as a reminder, this is the extra information that we get back once we've already learned that a PVD exists from the RA. We can go fetch other properties about it. This had previously been using a X dash scheme that is not recommended. So we said, don't use that, use a vendor dash scheme. And we also clarified much more about how the IANN registry and review would work for keys within this JSON object. We also registered the media type for a PVD JSON to be more explicit about what type of information this is. And we also clarified, based on I think some feedback from Eric Klein, the header values that we need for nested arrays, and we cleaned up some of the text there. All right, so that's what we already have. That was in the last call version of the document. So based on the review, we have a number of pending updates. Some of these are just editorial, so I can just cover these here. They're not quite as interesting. And for reference, this is the URL that we have of the document on GitHub. And if you want to download the slides and go follow that URL, you can look at our current pull request. You can comment, you can tell us what is good or bad about the changes that we're proposing, and that'd be very much appreciated. So as far as the editorial changes we're doing, we're shortening the abstract. It was a little bit too much, too wordy for an abstract, and we are expanding the introduction a bit, improving the flow based on some feedback from Ted, and clarifying some of the examples. We also added some more examples into how IPv4 via DHCP v4 is kind of coexisting in the world of explicit PVDs. This was already somewhat implicit in the text, but it wasn't really explained how it would work in practice. So to cover this, the thought is if you have two different uplinks, let's say a Wi-Fi provider and a cell provider, only one of them is going to be providing useful routable IPv4 all the way to the end client if I have source address selection for both. So I would be able to associate one of those explicit PVDs with the DHCP v4, and any additional information, let's say the service is offered by my Wi-Fi service that I discovered from that PVD's additional information, those could apply to the associated v4 connections, whereas the other link would be forced to be v6 only in this case. We also updated some of the references to how you handle case insensitivity comparisons for the FQDN for the PVD ID to just refer to how RFC 4343 does it, rather than trying to re-explain it on our own, which was not the best way to go. All right, so that's editorial updates. So these next ones are more content changes, and so these I would ask if you have an opinion on, is this the right thing or not the right thing, please do come up to the mic for each of these. Just give us a sense of if this is the right direction based on the working group's thoughts. So Ted pointed out that the way we were specifying the coexistence and integration of DHCP-v6 information with PVDs and with multiple PVDs that come from RAs was not correct. It was not really well thought out, and it didn't actually work. This is largely because I think this is not one of the major use cases that's driving this. We just need to make sure that there is some consistent way to fold in this information, something for the client to do. So we had some discussions, and thank you to Eric Klein and Lorenzo for giving some guidance. So let's see if this is kind of what we think we should do. What I have in the pull request currently is specifying that if you do have a DHCP message that does include addresses and prefix that's giving out to you, if those do match a PIO that came from an RA that is defining a PVD, then you can associate that information with the PVD that you have either implicitly or explicitly. If there is no PIO in your RA, or if nothing matches this DHCP v6, then that is essentially a separate implicit PVD interface. You cannot treat it as belonging to anything else. It's just kind of off on its own. And if you have stateless DHCP v6 information, something that's not associated with an address or prefix, then we just kind of associate that with any of the implicit PVDs on the interface, which is essentially the existing behavior. Just treat it with the implicit configuration for the device, but it's not necessarily associated with new explicit configuration that's coming through the RA. So is this a viable resolution to this problem?
Lorenzo Galudi, I feel that this is like dodging the problem and putting it and moving the problem to where we have to when we need to select the PVD. Because it's easy to say, well, I don't know where to put this, I'm just going to put it in its own box. But the problem is, let's say I'm on a DHCP-v6 only network, right? Which, okay. But yeah, I'm on a DHCP-v6 only network, and there's no PIO. So I've got an address, and I've got a default route. Okay, so that default route came from the RA. There's no containers, there's no PIO, everything is off-link. And so those should actually go in one PVD, because otherwise there's no single PVD that I can select that will actually give me any connectivity.
Do you want this to be compatible with an explicit PVD, or is this just to manage how I connect to things?
If I can't select a PVD, then what's the PVD for? Right, I mean, if it's only about the stack sort of like associating bits of things to each other, that's fine. But if I can't select something that's going to give me, connectivity, then it doesn't seem very useful. So that's what I'm saying. It's obviously like internally consistent. It'll work.
Yep.
It's just like when it doesn't turn out to be a very useful thing.
Okay. I think in that case, I'm imagining it just kind of falls into the existing behavior for devices, and you just use it as an implicit local route.
Basically, as soon as your DHCP6 request succeeds, 10 seconds after, like, oops, oh dear, now I've got this implicit PVD, now I'm going to fall through. Now everything on this interface is now also in this implicit PVD, even though everything else was containerized.
Wasn't it, like, isn't the
Let's say
current state?
Okay, so for DHCP6 only network, yes.
Yes.
If you have
Right.
Slack and DHCP6, let's say you do Slack and you get RDNSS, and then sometime later, so you get like, great, everything's containerized, it's in PVD 1, 2, 3, 4, 5.
Yep.
Awesome. And now, oops, oh look, I got an NTP server from DHCP6. Oh dear, and I'm like, what do I do? Like, I have to deaggregate these, this is PVD. And so now that DHCP6 stuff goes into the implicit interface PVD and.
I think Eric wants to say something, but Ted, go for it, Ted.
Yeah, so it just occurred to me when you read that last item that actually it doesn't make sense for stateless to only be associated with implicit PVDs. If stateless doesn't actually have a clear PVD that we can label it, that we can associate it with,
Yeah.
it really applies to every PVD.
Okay. Yeah, we can say that.
Eric Klein. So if you didn't have a PIO to match addresses you got, you could easily have an RIO that covers it.
But you can have nothing.
And then you know that it's, well, but operationally you could say this is require, right? If you don't want a PIO because you don't want a PIO, then you can put an RIO that's /64 that covers the addresses you hand out, and then you can identify that that's the explicit PVD you have to bind with. And then on the second thing I was going to say, I think there obviously will need to be some kind of operating system API awareness to discover that there's these PVDs, some implicit, some explicit, and have information. And nothing prevents an application from mixing and matching information.
That's
and
true.
Hoping for the best.
Yep.
Right. The PVDs are there to say this is a consistent set of information.
This is where we can guarantee is associated.
We don't guarantee that other combinations don't work,
Correct.
right? But
They may.
So they might work. So you could say, well, I learned about an NTP server. It's not part of any PVD, but it's part of an implicit PVD.
Yep.
I'll give it a shot.
Yep. That's a good point. Also, if you have thoughts on that, if you could write those down as like a comment on the PR or suggested text, that'd be great. Thank you.
Eric said yes. Suresh
Nope.
Krishnan. So one of the
Suresh.
things that concerned me, I looked at the pull request for that.
Thank you.
The thing that concerned me is like when you say what matches, right? So it said like addresses and prefixes match.
Yeah.
Right? So if I got a /48 in a IAPD, right?
Yep.
Which will match like a /64 in the PIO, right? Like, but it's like a subset of what came in the array, right? So like I'm just trying to understand like what would you mean by match? So I think there's like a bit more description required because I think it doesn't match in my head. Okay. So imagine it's like a foo /48 coming in IAPD. The router is announcing foo ABCD 64.
Yep.
Right. It falls under the 48, but I don't think it matches. So
Right. So we want a one-way inclusion. Yeah.
That's one thing. The second thing is like actually talk about the options. So I would talk about like IA prefix and stuff like that, right? Instead of saying prefixes and whatever, because we don't know what's going to be defined for DHCP6, right? So I would go into specifics.
The specific DHCP options.
Specific DHCP options and say like this is the matching algorithm.
Great.
Lawrence Cleary again. I do feel we should try to do better than this. I'm not quite sure how, but I mean, so one thing that we do today, right, is we use 6724 sorcerer selection, and it sort of knows how to do this mostly. It sort of looks at what's in the interface, and it's like, well, this is what I'm going to do, and it comes up with things that it thinks are likely to work. And I think that's maybe in the absence of better information, because like literally, if you're on a DHCP6 only network, then like there's no other configuration that's workable than to use the default route that you got from the array and the AP address that you have, right? So I think in the real world, it's actually going to be a lot more common that the configuration is going to work, because no matter how smart the hosts are, the network is still going to have to contend with hosts that aren't smart, and so it's probably going to have to make those work somehow. So I don't know how to write this in the draft, but I do think maybe we should. Maybe I wonder if we could say, look, we're going to augment the implicit interface PVD, and like essentially, unless everything is containerized, we would just put, we just upgrade the interface implicit PVD with stuff that is containerized or something. I don't know. And for PIO, by the way, I think it's fine to say configuration error, because the PIO can have no flag set, in which case I think it's in current standards it's just no up. It completely does nothing. If you set A to 0, L to 0.
So specifically, you're saying configuration error for which case?
In the case where you have, an IP address that doesn't match any PIOs, you just say it's a configuration error. The thing that was upgraded in the network when the PVD was added, the thing that was configured to add the PVD ID to the RA has to then add a PIO, and that PIO can have 0 flag set, which means it won't touch any hosts in any way. It won't affect anything.
Yep. Okay. Ted.
I'm too confused to say what I was going to say.
All right. So I would ask people who have comments and thoughts if you could just kind of add those comments to the PR here, so we can make sure we incorporate those and we can go back and forth on text. That would be great. Thank you for this input. I think this is going to be the most nuanced part to get right. Do you have something, Gory?
Are you doing more slides?
Yeah.
Okay, I'll wait for the whole slides.
Okay. All right. So other changes, I think they should be less controversial. In the additional information, Ted pointed out quite rightly that the fact that we had a name and a localized name in there, while those were cute, they are concerning, not really clear how you use them, potential security vulnerabilities or attack surfaces for spoofing. So I have removed those, and we are now just including the FQDN identifier, which is the identifier of the PVD within the JSON. It allows you to validate that this is indeed the correct configuration, and it essentially gives you a convenient way when you receive this PVD information to say, oh yeah, and here is the identifier for the rest of this stuff, so that's easy for an application or the system to consume. Does this make sense to people? You have nods. Does anyone have a problem with this? Great. Okay, moving on. We also expanded some of the security considerations. There are points that were just missing references and missing some explanation. So there's validation that we have when we look at the additional information to validate that the prefixes match the prefixes that you have been given. Kind of explain that a little bit better. There's also some text about how a device could try to intercept things and run a net66 to make it look like it is providing the prefixes that are detailed in the additional information, and so allow a client to think that they're talking through the real router, but they're actually have an intercept in the middle. This was explained and the mitigation was explained, but it was not super clear, so we reworked that text. The safety here is that the server that's actually running the additional information can validate that the client IP address that it's getting is within the range that it gave out, and so can validate that there is not some intermediate net66 there. And there's also just some text we added at the end to really make explicit that what we are giving you is not this is a safe, trusted network guarantee. This is really just about detecting if this is a intended non-misconfigured set of information to have two different networks coexisting at the same time. It does not really add any more trust than you would have on your Wi-Fi network today. So those are the main content changes. I think the main one we need to continue working on is DHCP v6. Once we clarify that, we'd like to publish an 06 version and then get some more review. And yes, please, other input. Hey, Dave.
Dave Fair. I want to comment on a new issue that's none of those three, but it was mentioned on your slide 3. which was the current, yeah, that one. Slide 2, sorry. Maybe it was slide 3. Someplace, anyway.
Okay.
Yeah, this is fine. Register the media type application PVD plus JSON. This triggered the the document right now does not contain any rationale for using JSON as the format of the PVD additional information.
Okay.
In the IoT industry, people would argue, we got CBOR parsers in our devices, but we don't have JSON parsers. Can't we get this information? So you should either argue this information is something that constrained devices do not need. That would be one rationale. Or you'd have to argue, and they need it so much that they should add a JSON parser.
Yep.
Or you should say, and here's how you could do it with CBOR. If you took the latter approach, the last of the 3 approaches, which I'm not necessarily arguing for, I'm saying you got to pick one of those 3 and put it in the document.
Yep.
Right?
Great.
If you do the last one, that means you say, well, which one does the router include in RAs? Does it do both or one?
Right,
so
right.
That's an issue that I think this document needs to address in at least one of those 3 ways.
Yes. So there was already a issue that was brought up kind of when we added some of this registration of, hey, should we do CBOR?
It wasn't on your list, and there's no rationale in the document.
Okay, great. Yeah. My reaction to not having CBOR in there currently, just to kind of say what I'll say in the doc, is I definitely don't want to have both and you like just present whichever one they ask for. Like that seems unnecessarily complex.
Option 3, you're arguing against that.
Yes, exactly. So we agree that we shouldn't do option 3. At least as far as I'm aware at this point, I don't see anything that's particularly important that would be driving IoT devices to need this, but
I mean,
yeah.
you either have to argue in the document that,
Yep.
and this information, you know, the expiry or the
Yes.
prefix list or whatever
Right.
is not relevant to IoT devices, and they should just ignore that. You either have to have that
Right.
rationale in there to make the case. Or you could take an approach that says, on some networks that might be constrained networks that don't have constrained devices, you might choose to send CBOR only instead of JSON. So you're not doing both. But you happen to know that it's like one of these low power links or something that's of this magic type, and everything on there is when it's constrained devices.
Yep.
Maybe do something different there.
Yep.
Right now, I'm just pointing out that the document itself should contain some discussion and a rationale, even if it sticks with the current approach.
Okay, thank you. Makes sense.
Paul Hoffman,
Paul.
who didn't get up here to talk about CBOR. I would. One thing that I did not get from the draft very well is the coexistence of things that are not addresses being assigned that still might affect other systems wearing my DNS hat, such as, you know, who are your resolvers?
Yes.
So as I understand it, and please, I would be very thrilled to be wrong about this. If you have multiple PVDs, it seems like you might have multiple resolvers, some from different PVDs.
Yes.
And some of them may, in fact, be for have different split DNS views or things like that. And there's no information coming down that says, in this case, use this PVD, because an application calling the operating system is going to have no idea what's going to go in. Am I correct so far?
Can you clarify the last part about the application? We'll have
So
no
an
idea.
application saying, I want an address for this domain name, just
Yes.
sends normal, you know, get adder info to the operating system. The operating system now has possibly 2 concatenated lists of
Right. So I think
resolvers.
this is not.
3 or 4.
Yeah, it's discussed a bit in the draft, but I think it's really relying a little bit more on the main MPVD architecture. I think very specifically, you should not be concatenating arbitrarily, right? So at least, you know, for our system, imagine each PVD becoming like an interface, like a separate interface, right? And so the interface has a resolver. When you do a get adder info, at least for us, if you are not specifying a specific interface that you are scoping your information to, you get the resolver for the default interface, and that's the only one you're going to be using. Then that if you explicitly select into another PVD, you use its resolver and its local address.
When you say you in that sentence,
The application must.
get adder info doesn't let you specify.
So get adder info alone is not PVD aware. It doesn't also let you access the cellular link if you are on a Wi-Fi network. So it does not do this. There are APIs both on Android, iOS, other platforms that do let you specify the PVD that you want to be resolving into. And that's what this relies on.
Okay, so okay, good. The last bit was what I was asking. You are relying on
Yes.
applications who are using these services like the NTP service or this.
Being aware.
Being aware and having a way of asking.
Absolutely.
Okay, I do not think that's clear in the document.
Okay, so there is a section on kind of the DNS client handling. We'll just make sure to indicate, I think what you want is the application's interaction to this.
Correct, especially around DNS. I mean, I love NTP, but DNS is sort of more used.
Absolutely.
So I think that it was funny because in your previous slide from this one,
Mhm.
you said these are just editorial changes. We're going to add examples. No. Examples are not editorial changes. Those are the things that help folks.
Yeah. That's great.
Okay, great. Thank you.
Thank you.
I was just going to, Eric Klein, I was just going to respond. One of the things that was in the process when MIF was shut down was an API document, an API requirements document.
Yeah.
So,
Okay, great. Thanks.
So Gary, first, I was going to say it'd been really good to call it the DNS thing, but you've done that. The other thing is you have backup timers, and then you have get a delay, and you must send at a particular time.
Yep.
Do you actually mean you must send at the time with like some resolution, or do you mean you must delay it by a certain amount of time and then transmit past?
Yeah, that would be good to clarify because it may not be possible with the reality of the universe. Yeah. Right. Exactly.
It just reads exactly like that if you read it.
Yep. Okay. If we have that in the notes, I'll make sure to clarify that. Thank you. Great. If there's nothing else, I think we will go on with our work of revising.
So for the security comments you got, they were all addressed already in your...
From the sector review?
Yeah.
We believe so. There was some of it that wasn't entirely clear to us on exactly what they wanted changed, but yes, we believe that is addressed. Okay.
Thank you. We can tell the reviewers to...
Okay, then aiming at this thing. Okay, Ron Bonica, and I'm from Juniper Networks. For about 4 years now, there's been work going on in the IETF to establish segment-routed, traffic-engineered, programmable tunnels. And there are two flavors of them, an MPLS flavored and an IPv6 flavored, depending on what forwarding plane you use. This is a proposal for another kind of IPv6 flavored. This is the 101 level expose on SRv6 Plus. It's intended so you can come into the Spring Working Group tomorrow and understand what everybody's talking about, because there'll be a very abbreviated presentation there. So what problem are we solving?
What is the fine print say at the very?
Juniper business use only. Oops, sorry. Whoops. Ignore that. I didn't mean to put that there. We want to implement a segment routing architecture. We want to encode path state in a packet as opposed to encoding path state or storing path state in a transit router the way RSVP does. We want to implement programmable paths, and we'll talk about what a programmable path is later. And we want to rely exclusively on IPv6. There'll be no MPLS anywhere in sight, and we want to leverage existing IPv6 features to the greatest degree possible. And we want to minimize overhead. A couple of reasons we want to minimize overhead. First, so path encoding doesn't take many, many bytes on the line. Second, so it's ASICs friendly. So to play the game, we need some terminology. The first is what's a path? It provides a unidirectional connectivity from an ingress node to an egress node. It can follow any path through the network, least cost, or a traffic engineered path. It contains one or more segments, and we'll define segment later. It's programmable, and we'll define what we mean by programmable later. And a path is defined by the segments that it contains. Just like a line is defined by 2 points, A path is defined by the segments it contains. Now, what's a segment? Well, a segment provides unidirectional connectivity from its ingress to egress. So we have paths that provide unidirectional connectivity and segments inside them. We'll see a picture of that in a minute. It's programmable, and we'll describe that a little more in a slide that's coming up. Its behavior is controlled by a topological instruction. It's executed on the segment ingress node. It defines the segment egress node, and it defines the method by which the ingress node forwards packets to the egress node. A segment is defined by its ingress node and the topological instruction that controls it, and a segment can be controlled by multiple paths. And there are exactly two types of segments. Strictly routed ones, they're similar to adjacency segments in SRMPLS. The topological instruction that controls a strictly routed segment forwards a packet over a specified link to the egress. And then there are loosely routed ones. The topological instruction that controls a loosely routed segment forwards a packet through the least cost path to the egress node. Now, next thing we have is the concept of a segment identifier. A segment identifier identifies a segment. It identifies that section of the topology. Because there's a one-to-one relationship between a segment and the topological instruction that controls it, a segment identifier also identifies the topological instruction that controls the segment. Now, a segment identifier identifies an instruction. It does not contain the instruction. Therefore, an instruction might take many, many, many bits to encode. A SID in SRv6+ needs to be only 16 or 32 bits long. SIDs are short. They also have node local significance. They're only processed by the ingress node. So, some things to zero in on. A SID identifies a segment. It identifies the topological instruction that controls a segment. And it identifies the instruction. It does not contain the instruction. Therefore, it can be short. Now, these are not the only instructions. We said that segments are programmable, paths are programmable. Yes, they have topological instructions used to steer from here to there. They're routing things. There are also service instructions. They augment the path, but don't define the path. A path can exist with one set of service instructions or a different set of service instructions. And we have two kinds of service instructions. One is per segment service instructions. They're executed on the segment egress node. An example, expose a packet to a specific firewall policy. Expose a packet to a specific sampling policy. You can see how these kinds of instructions might get used in service function chaining. Then, and these can be executed at the egress of any segment, the first, second, third, or last. Then we have per path service instructions. They can only be executed at the path egress node, at the egress of the final segment. They always talk about de-encapsulating a packet and multiplexing the payload, or demultiplexing the payload. For instance, a service instruction might be de-encapsulate the packet and forward it across this specified link into this VPN. Or de-encapsulate the packet, look up the payload destination in this VPN routing table, and forward it to the next hop that you find. Okay, the things we said about segments, this kind of is a picture to define it. Here we have a path. The path contains three segments, AC, CD, DF. A, C, and D are ingress nodes. C, D, and F are egress nodes. The topological instruction for AC is executed on A. The service instruction, if there is one for segment A, is executed on C. And the service instruction for the path, if there is one, is executed on F. Now, all this has been nicely theoretical. What does this have to do with IPv6? Well, paths are encoded in IPv6 header chains. Most everybody in this group knows what an IPv6 header chain is. There's a base IPv6 header. There are extension headers. SRv6 relies on 3 of them in particular. But before we dive into that, let's talk a little bit about how headers are encoded. There's a recommended ordering, hop by hop, that are processed by every node. Destinations that precede routing, they are processed by every segment endpoint. There's a routing header, also processed by every segment endpoint, and a destination fragment authentication, ESP, and then a destination that is processed by the ultimate destination of the packet. Now, you can see from this ordering a very natural way to encode instructions. Let's talk first about topological instructions. A very natural way to encode a topological instruction is in a routing header. Let's say we can probably, no, we have to go through the whole thing. The routing header has a segment list and a number of segments left. If segments left is equal to 0, you skip over it. If segments left is greater than 0, you decrement segments left, overwrite the destination address, and forward to the destination address. So you can see how that's a natural place to put topological instructions. Now, routing headers aren't used very widely in the internet, and there are, one of the reasons is the size. Most routing headers that are defined today define every segment as an IPv6 address, and they have 8 bytes of overhead. So let's say for a moment that you have a path with 5 segments. 5 times 16 bytes is 88 bytes long, and all of a sudden you have 88 bytes of overhead in a world where the average packet might be 700 bytes long. It's not going to work well. So we've come up with something called a compressed routing header. The compressed routing header, just like any other routing header, has a list of SIDs and a segments left in it. Each SID is either 16 or 32 bits long. You have something called an SFIB. It translates, it's a data structure, it translates a SID to an IPv6 address and the topological instruction that it represents. So as you're processing the routing header, you look at segments left, decrement it, look at the SID, look up that SID in the SFIB. You now find the IPv6 address that it represents, copy it to the destination, and forward according to the instruction. And that way you can get away with a really small routing header. And here's what the routing header looks like when you have 16-bit encoding and when you have 32-bit encoding. Now, let's talk about encoding service instructions. Service instructions we encode in a destination options header. And if it's a per segment service instruction, what we do is encode it in the destination option header that comes before the routing header. That's processed at every segment endpoint. And what we actually put in there is a 32-bit identifier. That's an identifier for the path. Every node, every segment endpoint that is part of that path, that has a service in that path, knows that 32-bit identifier. When it sees it, it executes the service that it associates with that 32-bit identifier. We also have a per path service instruction. The per path service instruction is also a destination option header. It's the destination option header that comes just before the upper layer header at the end of the chain. Again, it's a 32-bit entity, and it's a 32-bit instruction that tells the node what to do, de-encapsulate the packet and forward. So what are the salient pieces of SRv6? First, that it is very specific about saying what's a topological instruction, what's a service instruction. Second, it puts topological instructions in a routing header. Topological instructions have to do with routing. Seems like a routing header is a good place to put them. Service instructions, well, some of them are processed at every segment endpoint, and we have destination options that precede the routing header that are processed exactly there. That's the right place to put them. We have service instructions that are processed only at the end of the path. At the destination, well, gee, that's why we call them destination options, so we put them there. The other salient piece is we never try to encode an instruction in the segment identifier. The segment identifier identifies the segment, it identifies the instruction, it does not contain the instruction. Because of that, the segment identifier is short, and because of that, you can get away with a very short routing extension header. When you have a short extension header chain, it's ASIC friendly, and you don't have to do ugly things to keep your extension header chain short. The other nice thing about SRv6 is it doesn't change the semantic of the IPv6 address. You'll see the only thing we ever put in the IPv6 address field is an IPv6 address that identifies an interface. The IPv6 address never contains an instruction, it never contains anything else. Yes, it might identify a loopback interface, but that's the biggest stretch we make, identifying a loopback interface as opposed to a physical interface or a sub-interface. The drafts we'd like you to read, probably you won't get time to read them all. The first one's the important one, draft Bonica 6-man comp. I'm sorry. The first one's not the important one. Those are the other drafts. The draft we'd like you to read is that one, draft Bonica Spring SRv6 Plus. It'll be presented in Spring tomorrow and in 6-man the day after. Questions?
David Melvin Marvell. So do you see this as an evolution of SRv6? What's the vision?
It's not clear yet whether they'll coexist, whether they'll merge, whether it's evolution, all to be worked out tomorrow. Oh.
Purely edifying for me, for my ignorance. Is there a SID distribution protocol? Or is that all sort of?
Yes, it's ISIS. And in fact, well, actually, there are two of them.
Of course.
If you are, it's ISIS. The OSPF one hasn't been written yet. Those are the only two for SIDs, ISIS and OSPF. As for distributing service instructions per path, well, we have a mechanism for doing that. When the service instruction is encoded in MPLS, it's BGP. So we're going to reuse BGP. In fact, it's one additional flag in BGP that says, don't encode this in an MPLS label, encode it in a destination option.
Is that in BEST this week?
I believe it's an IDR, and it is, let's see, which one is that? It is draft Songli IDR VPN service SRv6 plus.
Okay, thank you.
Thank you very much.
Thank you.
So, move on. So, Vlad, are you able to join the queue.
So hey there. So I'm going to give you a quick update on SOX v6. So next slide, please. So the two major features that we're looking at in this revision are that the fields are all now aligned, and that the clients can have the proxy resolve addresses on their behalf and then relay the answers back to them. There are many more nits that have made it into the draft, but we won't be getting into those. There are too many to discuss. So next slide, please. So aligned fields are nice to have in any protocol, of course, and SOX has always suffered in that regard because of variable field lengths. Most notably, the domain names are variable in size. Now that the feature set of SOX v6 is rather mature, we've set out to refactor the protocol. So the only victim of this refactoring was the version minor field. So it's now called SOX v6 rather than SOX v6.0. Otherwise, everything made it intact in one form or another, but they've all been shuffled around. Now, all the figures in the draft now look like the figure on the right. You can see the request. Everything is neatly aligned, but it makes no sense for me to include all of the figures in this presentation. So next slide, please. So as I previously said, the domain names were the major thorn in our side. Now, we've decided to keep the usual format for domain names, but we've just padded everything to the nearest multiple of 4. It's rather straightforward. So here you see how the domain name for somesite.org is encoded. We've got a length byte, then the actual address, and then 3 bytes of padding. They're all 0. So next slide, please. So options also have undergone some refactoring. So first up, option kinds are now 2 bytes in size. Some option kinds used to have types and maybe response codes, but there weren't that many of them, so we've decided to flatten those. So the example I am showing here in the slide is the option whereby a proxy tells the client that an idempotence token was accepted. So the kind used to be idempotence, and then the type used to be called expenditure reply, and the response code was called success. So now in draft 07, this was replaced with an empty option that simply has a kind of idempotence accepted. Now, taxonomies for options still make sense for stack options, so those haven't been modified. But these flattened option types affect idempotence options, session options. So next slide, please. So this now for the other major feature. So we've added options whereby the proxy can resolve an address and relay the response back to the client. This is a non-standard feature currently available in Tor. So what we've basically done with it is that we've legitimized it. These options imitate this, that do address resolution, imitate the semantics of get host by name or get addr info, and not those of DNS. So the client doesn't get any kind of TTL. So the basic assumption is that you perform address resolution and that you're supposed to use the address in the immediate future. Next slide, please. So the way we do this is rather straightforward. Client simply sends a resolution request as part of the SOX request. If the client doesn't want to connect immediately to any host, it can do so. It can send the resolution request over no op. So it's so the proxy simply performs address resolution and nothing else. If the address in the request was a domain name, then the proxy sends back one option per supported layer 3 address. In this case, which is most likely going to be an IPv4 option, an IPv4 resolution option, and an IPv6 resolution option. If it supports resolving, for example, IPv6, but it cannot resolve the domain name to an IPv6 address, it simply sends back an empty option so that the client knows that IPv6 resolution is on the table. Now, if the address was a regular IP address, then the proxy performs reverse resolution and sends back a list of all the domain names. Next slide, please. So the first use case for this is UDP. So I've placed the SOX UDP header on the right. You can see that I've highlighted the address field in red. So all packets, all UDP packets that go through the proxy have to be prefixed with this header. If the address is a rather long domain name, then the client is going to have a lot less space to work with. I mean, for the actual UDP payload, it's roughly the equivalent of lowering the MTU. So it's far better to send an address resolution to ask for an address resolution over TCP, of course, and then use the resolved IP address. And then the UDP header is going to be a lot shorter. Next slide, please. So the other major use case is proxifying apps via LD preload. So you basically re-implement all the API calls that you want to rewrite, like connect, get header info, or whatnot, and then a client that doesn't natively use SOX actually ends up using SOX. Now in the current networking API, address resolution is done separately from the connect request. So clients don't know how to connect to a certain domain without resolving it first. So if we don't implement a replacement for get header info or get host by name, the application is simply going to have to perform its own DNS requests. Now, this is obviously bad if privacy is a concern or if DNS is censored. And also if it can lead to suboptimal use of CDNs if the proxy has a significantly different vantage point. So that's about it for me. I don't think SOX is in need of any more major features. And that's it.
Yes. Ben Schwartz, Google.
Hey there.
Hi. So there's a growing number of applications that need more than address records out of the DNS. One that's top of mind for a lot of people is encrypted SNI. And so it's true, as it stands, encrypted SNI is essentially not compatible with common proxy protocols that exist today, like including SOX. That is, if you want to do encrypted SNI through SOX, what you have to do as a client is form a DNS packet, query packet yourself, and deliver it as a generic UDP packet through the proxy with SOX-fied UDP to a DNS server of your choice. And the crucial thing from my perspective is that there is no way in this system for the client to direct it to a DNS server of the proxy's choice. So the application is actually forced to hard code some set of DNS servers. It cannot discover them through the proxy. So I'd like to consider that class of use cases here, see if we can come up with a solution.
All right, so my shame, I'm not really familiar with SNI, but let's talk about it. I mean, if that's a major use case for SOX, I'm definitely willing to add it in the draft and implement it.
Yeah, I'd certainly be happy to talk through that and consider what the options are.
Sure, shoot me an email.
Suresh Krishnan. Hello, Vladimir. So one thing I could talk to you about is like where should we home this work, right? And I was thinking like transport would be like a good home for it, like generally for this. And like I did talk to the transport ADs and Corey is right behind me. I think that it would be a good thing that you actually present to them, to the transport folks at least, about this work, and then we'll try to figure out where it's going to sit, because for me, it's got legs in multiple areas, and I really think the transport is the most relevant place to do this, but we can discuss that after, but at least present it to them.
All right. Do you expect me to present it to the transport session at this IETF? I could whip up some slides.
So Gary Fairhurst here, thinking on the floor as TSVWG chair. We've noted this draft at least existing in previous TSVWG meetings. I think we'd be quite happy to have a couple of slides and really see if people have read this and encourage people to read it, because before we do that, we can't really make a decision. But I think we should try this in transport and see if people will buy it, people will read it and comment on it there.
All right. So when's the TSV meeting? I could probably whip up some slides.
Thursday. Thursday.
Thursday. All right.
I
might not make it on. I might not make it on Thursday. I'm traveling.
Don't worry.
I'll write you an email.
Yeah. And we will mention it on our agenda.
Thank you.
All right. Thank you.
Tommy Polly, Apple. So thank you again for your presentation. This is it's a very interesting topic.
Thanks.
So a couple comments. I definitely like what Ben was saying about there are needs for more DNS answers that the application may want to be able to get. And even within the A and quad A answers, I have questions that are raised by this about what order are you giving those answers in? Are you actually waiting on the proxy side for both A and quad A responses? For example, we have guidance for how end client devices can do happy eyeballs, and ideally things would not necessarily have to wait for both V4 and V6 in case one is not coming back with an answer. So these are things that we could consider, and if we were passing DNS messages all the way through the proxy, maybe that would solve some of these issues.
All right. So my approach up until now was to create something that is simple enough and that covers the use cases that are currently in use by the Tor team. And I'm definitely willing to modify it to include more features more DNS-like features into this if there's a need for them, of course.
Well, I think a lot of this, the motivation here is not just to add features, but it's taking into account things that really are good protections for the application, like ESNI, or performance optimizations, like what we're doing with Happy Eyeballs, that maybe weren't around or weren't being considered in the original Tor design, but do make sense when you take into account the current situation of things. The other point I had was regarding the UDP and your use case for needing to do the resolution in order to do UDP.
You don't really need to do that.
You don't need to, but it helps you optimize, right? Mm-hmm. It helps you have short effects. You could have other schemes for getting that same effect, because presumably if you do the lazy way of just sending the host name every single time for every packet, the proxy hopefully isn't doing a new resolution for each time, right? It's remembering a mapping. And so essentially you're just establishing a flow mapping. And so you could kind of just do a similar thing of saying, I want to start this UDP flow, it's to this, and I'm just going to use token 1 and just have a very short field.
The thing is, UDP flows are not tied to a 5 tuple. So UDP flow is basically tied to an association, to a local association, to a local bind address.
Yep. Anyway, there are other things we could look at that you could separate out the issues of what we get back for rich DNS from the necessities of what we need to have efficient UDP proxying.
All right.
Okay. Thank you very much. So next is Dave.
Thanks for having me.
Thanks a lot. Good night.
Full screen? Yep. Thank you. All right, so last IETF, I presented an earlier version of this and the issues that had been brought up before that time. And since then, new issues have been brought up, and so it's been a rev to address those into 04. This document is being AD sponsored by Suresh and reviewed by this group and others. It was 01 at the time that I presented it in IETF 104. There's 4 issues. I've started using GitHub to track them. Those are the 4 issues. I've got a slide on each of those. And I'm going to cover them not in numerical order, but in order of biggest, most general down to the list most specific. Okay. All right. Here's the biggest one. Okay. This came up in lots of discussion around the software IF tunnel document that was doing the Yang module for IF types. Okay. And so there was a bunch of people and a bunch of confusion about, oh, this is defining a new registry, right? Shouldn't you be adding new values when defining a new registry, right? The resolution of that discussion is no, in fact, it's not defining a new registry. It's defining a new format for the same registry, right? You can't have different values in the Yang module than appear in either the MIB module or the registry that just lists them in a table, okay? It's really an alternate format of the same registry, okay? And so this was updated, or this was addressed in draft 03 by clarifying that they are just alternate formats in the same way as you can get registries, some registries in XML or HTML or CSV, and this is just potentially 2 more options. You could get stuff in Yang format or MIB format, but it's exactly the same values, just like the values are the same, depending on whether you get it in HTML or XML or CSV format. It's the same registry, right? So this tried to express that. So it was a new section that was added for this discussion, right? Because this wasn't discussed in the draft before, okay? This also talks about recommendations to IANA as to how to address this confusion in the website without being prescriptive about UI or whatever, just concepts, okay? And so the gist of it is that it proposes to present the MIB and Yang modules for IF types, and we'll see tunnel types, which is the other issues, as if they were available formats, not quote-unquote registries. So an example of what I'm talking about, if you look on the left side, this is an example of a page that has multiple available formats. You see XML, HTML, and plain text. This is actually on the same page as the one that's on the right. It's just way up at the top. There's one page that has multiple registries, right? The point is you have some descriptive text that talks about how you register a value, and you have some tables, and you have links to alternate formats. Okay. When you look at the IF type one today, you can see there's this little note that says for everything that's in the table, right, it needs to be updated in the IF type MIB and in the IF type Yang module, which are separate pages, okay? Separately down here, you see available formats, okay? So you can see how a reader would say, these are available formats, these are other registries that have to be kept consistent, hence the confusion, right? So the proposal is for IANA, and I was chatting with IANA earlier this week. I don't know if Michelle came into the room yet. She was going to try to be here for this, but this type of discussion here should ideally be represented as if they were available formats, which is more reflecting reality of how the allocation happens, right? And so IANA has to do various tooling issues and is doing tooling issues anyway as they're rewriting their system to say, hey, can you somehow incorporate this? So you can imagine down here in the ideal world, you'd see CSV, MIB, and Yang, okay? And you click on them and you get exactly the same values in all 3 of them. They're just available formats, right? So this is, if you have a hard time figuring out what I'm talking about, this is trying to make it be real as an example, right? And of course, the look and feel of this website may change over time, right? And so the document doesn't talk about that. It just says available formats, which is an IANA concept, as opposed to registry, which is an IANA concept. Okay, so that was the biggest change. And as a result, this one, the document, the software IF tunnel document is now in the RFC editor queue, right? This discussion helped to resolve that as well. Okay. Next issue. The tunnel type was mentioned in this document, and I talked about it a little bit at last IETF, but there was certainly not equal coverage, right? The document talked about IF types, right, and the registration for IF types. But the tunnel type registry is on the same page. It must always have the same designated experts. It must always have the same assignment policy by RFC. That's the requirement in the actual RFCs that must be the same. Okay, and so part of the expert review, because it has the same experts, myself and Dan Romaskanu, the same experts, part of our job when a request comes in is to verify they're asking for the right thing, right? They're asking for a tunnel type, and we could come back and say, no, you really mean a tunnel type or an IF type or vice versa, right? That's part of the review that we do, just making sure that they're asking for the right one, right? It's the same experts for both of them. One is a subtype of the other, okay? And so we said, well, given that pretty much almost all the considerations are the same other than a couple of language terminology, we said it would make sense to expand the document to add in and tunnel type in their various places. Okay, so we did that. Okay, and so as a result, the title changed to have and tunnel types in the title. Okay, the title used to just say guidelines and for registration procedures for interface types, and now it's and tunnel types, and now the treatment is equal. Well, that was the intent, but we missed one in 03, and so this one is saying, oh, we missed a spot, and so we needed to rev 04. We missed a spot, which is this one. If you look at how you ask for a value, okay, last time I talked about how you can either ask for a value by filling out a form, by going to the INS site and clicking on assignment and clicking a thing, and there's a specific form for IF types, or you can just send them email, and they'll accept it either way, right? But if you look for tunnel types, there's no form, okay? You just have to send email. And there's not actually any place in any document that says, here's the template you must use to fill out to pick your, the fields you have to fill out, even when sending email. And so as a result, for example, the IF type, even the old RFC, right? This sentence appears in the current one, which was copied from the older version of the Internet Interfaces MIB and the one before that. This template describes the fields that must be supplied in a registration request suitable for adding to the IF type registry. Okay, so that means as designated experts, we don't accept ones that are missing those fields. We send it back saying, please follow the must and send it back to us. Okay, we can't apply that policy to tunnel types, right? Because tunnel types have no must saying, here's the field you have to send us. So this kind of conflicted with this argument that says same assignment policy, but by the way, we can't apply the same thing because this must is missing, right? And so we said, sure, let's just specify a template because the questions are the same questions. So let's just say that, right? Okay. And so now if IANA wants to have a form, they could do that. The document doesn't comment on whether they should have a form or not, but now it's free to because there's a specific set of fields that this is proposing that happen to match the same set of fields as you'd specify for an IF type, okay? Other than they say tunnel instead of interface. Okay. For the last issue, I'm going to put this slide up. This slide I showed at last IETF, okay? Last IETF, I explained that there's subtypes like IF type 131 has different subtypes of different types of tunnels, GRE and Teredo and all the different things that come out of software and so on. So there's a subtype relationship between IF types and tunnel types. There are things that are alternate value relationships, and last IETF I explained that here's the IF type for Ethernet, and then once upon a time there was all these other values that were then later deprecated, saying, we really shouldn't define new values just because the maximum bandwidth changed, right? You should just use this one, so these were deprecated, right? But the point is there are cases that use alternate values for similar technologies. And there's cases where sublayers, right, where there's a demultiplexing relationship or what have you that means that it shows up twice in the stack from top to bottom, where IP or whatever is at the top and the physical network is at the bottom of the stack. Okay, so there's three relationships: subtype, alternate values, and sublayer. Okay, so the last issue was subtypes and sublayers had discussion in the document. Alternate values had none. And so there was a comment from Med who said so Suresh posted the mail out that says, hey, any feedback on adopting this or me AD sponsoring it, right? And one of Med's comments, one was covered by a previous one I already covered, and this is his other one, add some text to encourage UDP-based tunnel protocol designers to register their own code instead of reusing the one currently assigned to the JRAC UDP and CAP, okay? So it's actually touching on that alternate value thing, right? Because in one case back here, we said the IETF said you should not be using alternate value. You should kind of reuse the same one, right? And in the UDP tunnel case, this is a case where we actually want them to be different. And so what's the principle behind that? That's what this issue is filing. What's the principle behind that? And Dan and I said, well, there actually is an important principle behind here, okay, which I'll show on the next slide, the text that we added, because both of these decisions are correct, and we'll say why. Okay, and so we added this section called alternate values that talks about guidance for when you should consider using an alternate value and when you should try to reuse an existing one. Okay, and so on the UDP issue that Med mentioned, the UDP value, by the way, one of the reasons that it's problematic is the UDP value was originally added for this RFC 1234 encapsulation. Okay. RFC 1234 is a way of doing encapsulation over UDP that can also encapsulate multicast packets, okay, over a multicast distribution network, right? Many other UDP encapsulation protocols, Teredo and so on, cannot do that, okay? And so this notion that says, well, this particular UDP one doesn't really work for the other ones because the expectations are wrong, okay? And that gets to the core of this. It says, okay, we can generalize this problem, okay? And so in this case, when Teredo and these other UDP-based ones got their own value, there was a good reason for that. And that's what led us to this text, okay? After we discussed these two examples, we said these are both examples of correct ones. And so since they came to opposite conclusions, we talk about both examples in the document as guidance, right? So from this quote down to this quote is the actual text in the document right now. And I tried to format it just so you can highlight and see. It says, okay, there's two cases here, okay? You should use a new one, whether it's IF type or tunnel type. You should use a new one whenever key aspects, such as the header format or the link model, okay, are significantly different, right? So in the Teredo versus 1234 versus various other softwares one, the link model is significantly different. And so therefore you should ask for a new value, right? You shouldn't try to reuse UDP. You shouldn't try to reuse Ethernet or whatever. Create a new value if it's a new link model or header format, okay? But reuse the same value, like in the multiple copies of Ethernet example, if the differences can be expressed in differing values of existing objects, like link bandwidth, right? It's a separate object. You don't need the IF type to figure that out, right? And so in the Ethernet case, the only differences were ones that could be expressed in other objects already in other things in the same table, okay? So in the Ethernet one, this applied, and in the UDP tunnel case, this one applied, and this gives a more generalized guidance that is hopefully reusable in future requests. I think that's my last slide, so.
So this is really good. Like, so I was the one who raised the issue for UDP on the software document. So that's where, like, Med kind of like, because I was confused that like there's like UDP and UDP based tunnels, and like it's really good that you like solidify like the difference between them. So I'm really happy that you did it.
Okay, great, thank you. Okay, so all of the issues that are addressed in those ones are ones that were raised since last IETF based on the two calls, right? The IETF last call on the softwares document, and then Suresh's call for AD sponsoring this one. All of these we believe have been addressed to people's satisfaction, so we don't believe that there are new issues, okay? And so I'm just reporting that out, that we think that our job is done until any new issues are raised, and we invite the community to raise any new ones.
Suresh Krishnan. So my goal is to send it to IETF last call very soon. So I think probably just after this meeting. So I don't want to. I don't do IETF last calls during IETF week.
Sure. Yeah.
So like that's something I'll just like push up.
So I see Michelle came in. Is there anything else you wanted to add? I did mention that the tooling issues IANA was investigating in the future, and so exactly how things would affect a website was something IANA would decide. I just mentioned here's the principles from the community for IANA to take into account. Yes, thumbs up. Okay. For me to echo, that was just a thumbs up from Michelle on behalf of IANA. Okay. Coming back.
Gory first has to do with the other bits of UDP tunnels. Is there anything that transport area needs to help with this? No?
Don't think so.
Shall we just mention it's going to last call, if that's what's happening?
The only other, right. There is an area that we want to get specific review from, which may or may not affect this document, which is ops area, right? Because this this first issue here comes up whenever you have a case where you want a MIB and a YANG module to be defined as having always the same values, and they must never differ. So allocation of a value affects both of them, right? In theory, this might actually be a precedent for other cases beyond IF type and tunnel type. I am not the designated expert for any other ones, okay? So I am setting a precedent here that the ops area AD or whatever could choose to use in other cases here. That's not what this document is doing, but the IETF could choose to do that.
So Deborah Scribe here, speaking for Dan Romanescu, he said that transport area and OPSD review would be welcome.
Yeah,
which is basically
right. That's my co-author saying that. Thank you. Okay.
Diana, just to go back on how you mentioned that we're looking into tools, I do want to raise that, I don't know timing-wise how long that's going to take.
That's right.
It's going to have to take resources. So I would be a little concerned with, of course, you go to IETF last call, everything looks good, it gets approved, might be sitting for a little while. Now, an alternate thing to do there is if there's something in the IANA consideration section that says, and I'll try to find the document who did something similar, basically says that you're going to work out the tooling, but the publication of the document doesn't need to wait for that. So if I can find what I'm thinking of, I'll send it to you, and maybe the working group wants to consider that, so you don't have to wait on publication for us to do what we need to do.
Right. We consider this just requirements for the registry. The actual implementation will lag the requirements, obviously. So, yeah.
Okay. Thanks, everyone. So that's it. See you next time. Does anybody see the blue sheets? Ah, thank you. Yes, thank you. Thanks, Michelle.
Just in like a nick of time.
It's being signed again for some people are signing. So what's the protocol? The blue sheet? We just
Yeah.
should I?